Let's say that you're developing a 2D top-down shooter game, kind of like, I don't know, Smash TV or such classics like that. And you can have multiple players at the same time confronting a bunch of enemies. And I mean a bunch of enemies, like 10 or 20, maybe even 50 at the same time, because you want that real carnage in your video game. And as a top-down shooter, well, your players and enemies are shooting bullets at each other. Now, given 1 second of gameplay, how many bullets can we expect to be shot? Potentially hundreds. And what's the lifespan of these bullets? Okay, maybe a few seconds. So we can expect possibly thousands of bullets on screen at any given second in a game. Well, maybe not any given second, but during the frenzy parts, during the core gameplay parts. Now, what do we do with these bullets that we need to shoot? Do we create them dynamically? So dynamic instantiation, every time we require a new one. So every time a player, character, or an enemy shoots, do we instantiate a new bullet? If we do that, well, as we just quickly analyzed, we might be doing potentially thousands of instantiations per second, or in the span of a few seconds. Even though we won't fill up our RAM because we can destroy the bullets, we're still doing allocations, we're still instantiating objects in memory. Now, that can have a significant hit on your FPS, on your performance. If at a given moment in your game, all of a sudden you have to instantiate 3,000 bullets, well, that's 3,000 new allocations you have to do in memory. This is why video games will typically not go with that solution. During loading screens, we will pre-instantiate every single bullet we would potentially need. So if at a given moment in the game, I know that there should never be more than 3,000 bullets, I can just instantiate 3,000 bullets during a loading screen and then deactivate all of them. These 3,000 bullets are placed in a data structure called an object pool. And then whenever a consumer of the pool, like let's say a player, needs one by shooting, we take any bullet from that pool and then we reactivate it, reposition it, and give it the correct orientation to move forward towards the target that was, let's say, selected by your mouse, because you can control your game with the mouse and you point at the enemy and then you shoot in that direction. So that would be the better design pattern here. So object pool is a design pattern in object-oriented programming, but it's a general concept that you could use in different paradigms of programming, I guess, even if object is part of the name here. So what are other examples? There was a project where you were turning a bunch of humans into zombies, if I remember correctly. Well, in that case, let's say, depending on implementation, you might want to destroy the human characters and then create new zombie characters. Well, instead of during gameplay, like destroying the human characters and then instantiating new zombie ones, you could deactivate the human characters, put them back in an object pool, and then grab or take zombie characters from the zombie object pool and activate them and reposition them at the correct place and initialize them with the correct attributes. So that's what we're going to be talking about today, how to actually go ahead and implement all of this in C# and in Unity. So we are going to start by implementing a very simple object pool data structure in C#. And this will not be a mono behavior. It's completely decoupled from Unity. We want this generic data structure that could be used in multiple settings. So we're going to call it object pool. And just quickly here, we're going to try and draw out this functionality. So an object pool will contain, well, different objects. And we want to, I always have a hard time pronouncing this word in English, but parameterize the object pool with a type. So an object pool of what type means an object pool that contains what kind of object. So let's say if we go back to our example of bullets, it could be an object pool of bullets. Specifically in Unity, we want an object pool of game objects, however. But it could be an object pool of really any type. So let's say of type T. And our object pool will be implemented not with a typical vector or array or a linked list. We're going to use something called a concurrent bag in C#. And we can kind of like imagine it as this bag full of type T's. So let's say this bag contains 5 instances of type T. In Unity, it would most likely be of type GameObject. Now, we're going to also need a way to consume or take. So a consumer in client code will request to take or obtain an instance, and then it's going to take any one of these and return it, let's say to the consumer. All right. And the consumer can also make another request, which would be to add. So I'm just going to change color here. Let's say pink. So take is in white, and then the consumer can also put. So this is more of a unidirectional request. So we can put. And we're going to take like a type T and put it inside the bag. And add it in. Now you can definitely have like a specific limit to the number of objects within the object pool. You can also have one that resizes dynamically if you implement it with a vector or a list. We don't really need to think about the specific implementation of this bag object. I'm just going to write it down here in white. It's called a concurrent bag in C#. So we won't talk about how this concurrent bag is actually implemented. What's important to know about it in terms of its like abstraction is that the order doesn't matter. So let's say I put an object inside the bag and then I take one. Which one will I be receiving? The one I just put in or previous one is going to be like first in, last out. It's going to be random. It's going to be last in, first out. It doesn't really matter because in this case, we just take any one of them. Order doesn't matter. And we're going to reactivate it and reposition it and reorient it and set up other variables, other attributes, other properties of our object. And then, let it go. So concurrent bag, order does not matter. And that's pretty much it. We're going to go with something really simple. What's this concurrent, however? Why is this qualifier attached to the word bag? It's just because it's thread safe. So let's say I had 2 different threads trying to take or consume a object from the bag. You're guaranteed that both threads will not return the same object, so you don't get any cloning or duplication happening. It will lock. Same thing with, pudding actually. Now if I think about it quickly, there shouldn't be any race conditions. Unless it depends on the implementation inside. Like let's say this concurrent bag is implemented with an array and the next position to put an object is tracked by an index. If you have 2 things trying to put at the same time, it might put at the same index and then you're squashing one or overriding one. So again, we don't need to really think about that, although it's interesting. All we need to know is that putting and taking is thread safe because we're using the concurrent bag from the .NET library. Okay, so what I have here is a new project opened up in Writer. It's a new C# project. It has nothing to do with Unity. And I have my program class, which contains my main function. And here on the left, I have an object pool class, which is what we're going to be developing right now. And then we can test it in the main. So going on what we just described, we need a take function, a put function, and we're going to be using a concurrent bag as our underlying data structure. Okay, and this underlying data structure does not need to be public. Obviously, we want to create like an abstraction above it, above the concurrent bag, which is the object pool itself. So we keep this private and type is concurrent bag, and we're going to see this using, so we're going to include system.collections.concurrent, which includes a bunch of concurrent data structures, namely the concurrent bag, and which type? Well, type T. Okay, and we can see here that, well, T is not defined. That's because we need to add it here for generic programming in C#. Now, generic programming is a bit different than in C++, but it's pretty similar to other more, I guess, high-level object-oriented languages such as Java. So I think in Java it's pretty similar to this, where we just add a certain name to the type that will be defined later on. T is pretty much a standard in C#. All right, so our concurrent bag will hold type T instances, and I'm just going to call this, well, bag. Okay, and let's continue with our methods that should be part of our public interface. So client code or users will need to consume and put, so we make that public, and I'm going to call this first one that returns a new type T, returns an object that we want to take. And I'm not giving it any indices because, again, I don't want to take any specific one out of the bag. I just want any one. Okay? So I'm going to take my bag, and I'm going to call a method here called try_take, which is like try parse. So it's not just take. We can see by the note here that it returns a Boolean and not a type T. So try_take will attempt to return an object from the bag, and if it cannot, it will return false. If it can, it returns true. What happens with the actual object that we want to return itself? Well, it's passed through this out parameter. Now, I mean, not everybody loves out parameters. Some people prefer returning like a tuple or tuple, I think in English, in this case, but I think an out parameter works fine here. So we're just going to try take, and well, we have to feed it something. Now, if I remember correctly, in newer standards of C#, I think I can just declare my thing right here. So I'm just going to call this like result. And oh no, we can't. So too bad. I'm just going to declare it up here. So I'm going to have a type T result, and this value will be set by try_take. And I basically just want to end up by returning my result. Okay. Here I'm not doing anything, however, with the return value of try_take. So let's say that it was false. I'm just going to return result anyways. What will result be in that case? Probably null. And that's not great. So we could do a quick check here. We can check, actually all in one line, if the result, or I should say the return value of try_take is false. So I'm just going to add this here. Then I want to throw an exception. So throw new, and I could give a specific type of exception here. Why would taking an object from the pool, or more precisely from the bag, not work? Well, what if our bag is empty, right? In our case, I think that's pretty much the only issue we could have. So if we try and take an object from a bag, I will precise here a bag that is correctly instantiated, like a bag that exists, that's not null. The only reason why we shouldn't be able to take an object out of it is if it's empty. So I might as well just create for myself a new exception class to be really not verbose, but I guess specific. Like I'm going to create an exception that the name itself describes the problem. So public, or actually I'm going to define it here. Private class bag, or even better, object pool empty exception. And I'm going to derive this from application exception. Now let me just make this a bit bigger for everybody. Okay. There we go. So this class will only be used in the object pool class, which is why I'm keeping it inside or nesting it inside the object pool class. What's application exception? It's a type of runtime exception. So it's not compile time, because we can't know once we're going to take, I mean, we're not taking objects at compile time, right? We're going to be pulling these objects out of the bags, out of the object pools from runtime. So application exception is a type of exception to represent runtime problems. Okay, so now I can throw this new object pool, object pool empty exception. There we go. And the name of the exception itself gives us all the information. As developers, I don't need an added message here. I will just see, like in Unity, for example, object pool empty exception appear in my console, and I know right away what my problem is. Okay, so let's see, I'm getting a hint here. Oh, there it is. I just forgot something really simple. We can inline our out parameters in the newer standards of C#. I just had to actually specify the type of the new variable I'm declaring, which makes total sense. Okay, so this seems pretty good. And also one thing I want to note, I'm making the exceptional case of calling take the branch in my if. In other words, most of the time when I'm going to be calling take from an object pool, it's because there are objects in it. It is possible that I call it when there are no objects in it, but that is not the common case. That will be, more of a rare exceptional case, which is why I'm throwing an exception here. And I'm making that, the branch. So it's not like the typical flow of my program. If you imagine it as a river, it will typically go straight without branching off when I call take. And that's a good thing to do when we're creating our if conditions, because our processors will be able to do branch prediction better. So we can pretty much have this if at almost zero cost. Not zero cost exactly, but we're making it less costly than if we made this like different. Like let's say we did this. Well, now we're kind of, I'm not so sure how this is going to get compiled down in C++ for the Unity case, but I feel like this is less optimal for the compiler and also for branch prediction. If I did code like this, so this would be better. I'm making the branch the exceptional case. Take this path only in the very rare occasion that you would need it. Otherwise, predict that you don't even need to consider it, because most of the time you're just going to take and go straight up to the result. Okay, now what else do we need? We want put, so we're not returning anything, we're just putting in an object. I mean, we could return a Boolean if ever we wanted to add some functionality saying that, well, your bag is full or something, but we're going to make this bag pretty dynamic in terms of its size. So I won't return true or false. I'm just going to take as a parameter the type T that I want to put. So I guess say object to put. And this shouldn't return any problems or create any exceptions. I'm just going to write this out on one line. So I'm just going to take my bag dot add. So that's a method that exists in the concurrent bag data structure or class. And I'm just going to put, I wrote it here in French, object, there we go. Object to put, okay. Now note that if I instantiate an instance of object pool, I'm going to have a problem because my bag here is never actually initialized, so it's null. So yeah, good luck calling null.tryTake or null.add. You're going to get a bad time. So I'm just going to add a constructor, and I guess I will put it here. Public object pool, and again I'm just going for like the easiest thing possible. Bag equals new concurrent bag of type T. And that's it for our object pool data structure implemented in C#. We could make it more robust, add functionality, add more debugging potential, more error messages, but I think this is sufficient for our needs. All right, so let's do a simple test. Let's create a new object pool, and we're going to put, let's say, randoms. So random is a type in C#. There we go. In the system library, .NET, okay. And I'm just going to call this pool. Let's define this newly declared variable to a new object pool type random. Okay, and yeah, it's quite redundant, so we can use the equivalent of C++'s auto in C#, which is var. Okay, and so pool dot, I can put and take the two methods that I want, and let's put a new random in it. So new random. There we go. And now let's also try and take pool dot take, and that should return a random. Let's call it random R1. Okay, and then I'm going to do the same thing for R2. So I'm putting 1, taking out 2, and let's take a look at what happens. Okay, right? Object pool empty exception. And that happened when we tried to execute line 12. So pretty basic stuff, but at least we have proof that it's working as expected. Now, of course, in a real great project, you would have unit tests testing every single aspect you can think of this data structure, making sure it's robust and valid, but we don't have time for that. So let's move on. Our next step is to take this object pool class and use it in a Unity application. We can quite simply copy this class and paste it into a Unity assets folder. Now, that would be really easy to use. So I could create a new component in Unity and then just, instantiate a new object pool, give it a specific type, like game object, and that's it. Really simple going from C# to C#. I mean, I'm taking for granted here that there are no namespace conflicts, but in this specific case, the way we wrote our class, it should be fine. However, there are alternative solutions to taking some data structures or algorithms that we created decoupled from Unity and then just using them in Unity as one of many potential applications of that source code that we wrote, of the data structures and algorithms that we wrote. We want to keep things modular, right? It's cool that this object pool can be reused in a bunch of applications, not just Unity applications. If you're not interested in this other way of going, which is by compiling libraries, and you just want to go back to the meat and potatoes of this lab, which is the object pool utilization, feel free to skip the next couple of minutes. For those who are still here, Let's talk about like managed code libraries and binary libraries and interoperability between C and C++ and C#. So the other solution to this, which is a cool software engineering practice that I really like, would be taking our object pool source code and other algorithms and things related to it and compiling it down to a library. If we start with C# source code, we compile it down to a managed code library in the format of a DLL, so a dynamic linked library. And what is managed code exactly? If you're familiar with Java, you could think of it as bytecode, I guess. In C#, it's called IL, intermediate language, but oh well. So that managed code that you're getting is really easy to use in another C# application. Since you're basically going from C# to C# or IL to IL, however you want to see it. I'm not even sure myself which one it really is at the end of the day for the interpreter, but it's really simple. If we go into our Unity project and we import our C# managed code library, it's really simple to use. We can start instantiated object pools right off the bat, just like if we had any other type referenced in our project. So like on the right here, I can use randoms from the system library, while I can use object pools from my, object pool library. Now, things become even more interesting if we start thinking about interoperability. I hope I'm pronouncing that correctly. Where we can interop and marshal between different languages. But more importantly, between like native code languages, C and C++, and managed code languages like C#. So we could compile our object pool and things related to it in C or C++, and then using interoperability, which is platform invoke in the case of C#, those functionalities, that native C or C++ code in our C# project. Why would we want to do this? Well, for certain things, it might be better or more appropriate to do it in C or C++. Things that you want really precise memory management and you're really, really convinced that you can implement it more optimally and with more performance in C or C++, you could go ahead and do that. And then compile that, service that you're trying to create in C or C++ into a library that can be reused in a bunch of other applications. Notably, even in C# applications, or in Java, or in a bunch of different languages. That's what's so great about these native libraries, that you could call them from a bunch of different front-end languages, like Python, for example. Now, how does this actually work in the case of Unity? Well, you would compile down your C++ library, and then you would create a C# wrapper, which is basically like an API or a public interface or a front end, whatever you want to call it, that allows you to have, C# function calls that in the back end, their implementation will really call the C++ or C native code implementations. And when I said specific to Unity, well, that's kind of how the Unity engine functions. The Unity engine DLL that you see being imported on top of scripts, so like using Unity engine, that's just this big C# wrapper, basically. There's not much logic into it. It's just like bookkeeping, I guess, or a boilerplate code, where it's providing you a C# API to call C++ functions defined in like the back-end Unity engine native code library. And that makes a lot of sense because Unity, its engine, is programmed in C++. What you're doing in your scripts is, well, you're scripting, right? The connotation to scripts is that you're just at this superficial level and you're calling a bunch of back-end implementations, which are coded in a way to be really performant in like a systems level language, C or C++. For example, if you're working in neural networks, you're probably working in Python. Yeah, Python is not the quickest language, so why are we using Python for something so compute heavy like neural networks? Well, I mean, if you're using a framework like PyTorch or TensorFlow, all of the computation, all the backend, everything that you really need in terms of logic is done in C or C++ or CUDA and stuff like that. So you're just at this superficial level where you're setting things up and you're calling functions, but the real meat and potatoes of those functions are implemented in these back-end system level native code libraries. All right, so that's all I have to say about that. And let's carry on now. On the right, you can see a new Unity project that I've created. This one is based on the URP template. However, I removed some of the extra objects in the scene and changed the project here a bit. I've added a new folder, for example, called source. And within this folder, I have two subfolders, code and scripts. Scripts are for all of our monobehavior deriving classes, so our components, in other words. And code will contain, well, our generic C# classes and structs, such as the objectpool.cs file that we just created. So plain old vanilla C# in code and everything Unity specific in scripts. Now, speaking about Unity specific stuff, we're going to create an object pool component. For now, it's empty here. And this will act as the bridge between our object, so our object pool object, to be more precise, and, well, our Unity engine. So we're going to create this component that will manipulate our object pool data structure that we just created. And it will allow us to do things in the inspector and instantiate game objects and whatnot. So this object pool component is client code to our object pool class that we defined earlier on. All right, so let's start. The first thing we need in our object pool component is, well, an object pool. What type should it be? An object pool containing game objects. So private object pool of game object. I'm going to call this my pool. Okay. And what else could we do now? Well, we're going to want to fill in this pool, right? So I can already start thinking about a method here called fill pool. I'll make it private, however, and we'll see why soon. So private void fill pool. Okay. So we're going to need some implementation there. Now, we know that we want an object pool of game objects, which could be any kind of game object. Could represent a bullet, a player, an enemy, a cannon, whatever. But which one of these game objects should we, copy to fill in the pool? We can use a technique that we saw in the dynamic instantiation part of Lab 1, where we can just pass in a prefab or basically any game object to this object pool component and use that as a basis for cloning. And we can put each new clone or each new instance based on the prefab or given game object into that object pool. I'm going to allow the user to select the game object we want to use as our basis here. So I want to call this private game object to pool. Okay. And how many clones of object to pool do I want to create? Let's say we allow the user to give a value for that as well. So serialized field, private int, I'm going to call it pool size. Okay. So I know that I'm going to want to take my pool called take and give it clones of object to pool. So we know the instantiate method, once again from Lab 1. We want to instantiate our object to pool. I did take here, and I want to write put, sorry. Okay, and remember, this version of instantiate will not reposition or reorient or even set a parent to the cloned instance. So all it does is just quick deep copy, and it will put the new clone in the scene, and it will also be active, which we don't want. So this kind of code here that I'm starting with doesn't work. We can't all do it inline. I'm going to want to instantiate my object to pull. So this returns a game object. I'm going to be lazy and write var here. So I'm going to call this, I don't know, I can call it just clone. And I'm going to want to put that clone into the pool. And obviously I want to do this pool size number of times. So I can create a for loop for that. All right, so for int I equals 0, I smaller than the given pool size, plus I. I'm going to create a clone, put that clone in the object pool. But before doing so, I'm just going to deactivate. So set active to false. So when I'm going to fill up my pool of pool size number of game objects, I'm going to set all of them to be deactivated. They're still going to exist, they're still instantiated, they're just deactivated, which means that we're not calling their awake updates and a bunch of other things. So we don't have to worry too much about performance. Of course, they occupy space and memory, but that's what we want. We want to occupy all the space and memory in one go, so we don't have to start doing allocations during gameplay and risk having FPS drops. Okay, so another note here, right? This could be multi-threaded, where I could create multiple threads to fill in the pool. Let's say that I wanted a very large number of objects, so I had a very large number for pool size. At a certain point, it's probably better to have multiple threads, filling up the pool, and we could do this easily because remember that our object pool is thread safe because it's implemented using a concurrent bag. So even if I have multiple threads, trying to put game objects at the same time, new game objects at the same time, it will still work. So that's pretty much it for fill pool. Now, of course, my pool itself isn't instantiated, so I'm going to need to do that. I don't have constructors in model behaviors, obviously, but I do have void awake for my initial setup, and I'm going to fill pool. Okay, but before that, as I was saying, this needs to be instantiated, so pool equals new object pool game objects. There we go. So that's pretty much our basic setup, and now we're going to add a few more things. For example, we're going to allow other components to reference an object pool component and call take and put. I've written down the code here. You can pause the video and take the time to copy it, but allow me to explain what's going on. So on line 30, we have this put method for our object pool component that takes as a parameter the game object that you want to put into your pool, and we're just basically delegating here. So the real logic for this method is done within our pool data structure, right? This one right here, our object pool in this other class, which actually, funnily enough, is really just delegating to the concurrent bags implementation of add. Okay, and similarly, take is just delegating to our object pools take method, which at the end of the day is really done in this try take method. So the real backend implementations, I guess you could say, is done in the concurrent bag. So it's just like this chain of delegation. No problem there. I guess you could even call this something like MVC-ish, or at least we could try and find a comparison between this and MVC. You could say that the object pool is your model, and most of the logic is inside of it, and then our object pool component is our controller that just delegates to our model's logic and acts as a bridge between the model, so our object pool, and the Unity editor, which would be the view in MVC, where we can, manipulate that underlying model, that data structure, through the view, thanks to this controller, which is our object pool component. So I don't know, that's a fun way of thinking of things. All right, now let's move on to something else. Let's move on to using this in the editor, actually. Here, I've created an empty game object and named it projectile pool and added an object pool component to it. I've set the pool size to 20 and I've given it a prefab that I created. So this prefab for now is very simple. It's just this empty game object called projectile. So my pool is called projectile pool, and I want it to contain 20 projectiles. Now, obviously, this is a very small number for this example. In a real game where we're shooting a bunch of projectiles, you would have, hundreds or thousands, potentially. And just a quick note on creating projectile pools. What's cool is that not every single enemy will have its own pool. So you can have just one projectile pool that all enemies can use when they're shooting. And also players, actually, most likely. Which means that we only have one data structure, which might be, very, very big instead of like many data structures that are small, which can seem like a downside, but it has a lot of positive effects if we have all of our projectiles, in one big continuous block of memory. I didn't mention this, but the concurrent bag is continuous in memory, so it's not a linked list. That means all of our projectiles will be in one big block of memory. So this could be, a problem if you don't have that much memory, but nowadays things have gigabytes of RAM, so I think it's okay. And we get this really cool benefit when everything is continuous in memory. That means, for one, we don't have a bunch of different data structures that we need to dereference. So if every enemy had its own object pool data structure associated, that means every time an enemy shoots, I have to go dereference, that object pool, and there's overhead to that. But even better, it means that if I'm loading my object pool data structure into memory, I'm not fetching a bunch of other weird garbage with it. So if I had a bunch of object pools in memory at different locations, let's say I get the first one, I'm fetching some things in memory and I'm putting it into my cache, and I might get other things that are not related to my current problem with that. So I'm getting like this first object pool, which is short. I'm using it for my first enemy, and then I have to go and load another object pool which is further in memory that wasn't brought into my cache, that wasn't fetched previously. So I'm referencing for one, and then I have to bring the new thing into my cache, knocking out previous things, bringing in more garbage I might not need from my RAM into my cache, and then doing the whole thing over again. If I had one object pool for all my projectiles that I need in my game, I have them all continuous in memory. So when I go fetch that block of memory, I'm going to fill in my cache with as many projectiles as possible, not too much garbage, or probably even zero garbage, and things will stay hot on my cache for my processor. The latency of going from RAM to CPU cache is non-negligible. Actually, newer design patterns for video game development, like ECS, that I've alluded to a few times in the past, is completely based on this idea of keeping your data, compact, continuous in memory, and hot on the cache to reduce the latency of fetching things from RAM and bringing it onto CPU as much as possible, because cache misses are expensive in terms of the time it takes to perform. All right, so that was my little parenthesis right there. Now let's carry on. Let's finally do the test that I've been talking about. Sorry for taking a tangent. I have a bad habit of doing that. And here we go. Okay, I have a bunch of projectiles. Projectiles 0 to 19. But wait, where do these names come from? And actually, why are all of these projectiles children of this projectile pool game object? Well, you might have noticed, but I've actually changed my fill pool here. I made it a bit more complete. So I've added this clone.name. I'm saying the name of each one to its base name, which is defined here. So the base name is just basically the name of object to pool. In this case, we're giving it projectile. So projectile space I. So start at 0 and at 19. And I mean, you could quickly adapt this for multi-threaded as well, right? You could have like 4 threads, the first one starting at 0 and creating 20, then the second thread starting at 20, going all the way up to 39. Sorry, so the first thread will do 0 to 19, second thread 20 to 39, and then the third thread would do another 20 more, and the fourth thread could do another 20 more if you wanted 80 total. So this could easily be adapted for thread work, multi-threaded work. And the other thing that I did, well, I've used this 2-parameter version of instantiate, where I can just give the transform here, set the parent relationship. So transform, this will be the transform of an object pool component instance, just like this one right here. So I'm setting all of the clones as children of this projectile pool game object. I went along and added some stuff to my very simple projectile prefab. Now I have this root game object called projectile still, but I've added a move component that takes a velocity. You can see the implementation here on the left, which is very simple, just translating by velocity times time dot delta time. So this here in the inspector means move forward 5 units per second. The units in Unity are meters, so 5 meters per second, using your local z-axis, so this blue axis right there. And here I just have a simple capsule, nothing more. Now we want something to use our projectile object pool. Let's go along with our spawner component from Lab 1 and adapt it to use an object pool. So just as a refresher, our spawner component is just something that, well, spawns in a game object. And we're just going to change our definition of spawning here. It's not instantiating something new on demand. It will be activating a game object that already exists on command. Said command will be called spawn, just like in Lab 1. But what's really cool here is that we can plug in an object pool component, such as projectile pool, to any spawner component. And the spawner component will take from that given object pool. So I could have, let's say, multiple enemies, and the enemies have weapons, and each weapon has a spawner component. But each unique spawner component will reference the same object pool component, the same projectile pool, to corroborate the example I was talking about earlier on. So this is pretty incomplete right now, my spawner component. I still have a bunch of things to do, but this is like the general idea. So again, I can give it an object pool component, and then I can call spawn that will take from that object pool component, right? So this take is this one here. And now once I've grabbed an item from the pool, and just to make things clear here, when we take, we're not removing anything from the object pool. Like we won't see, okay, here let's say I have my 20 projectiles. If I call take, I'm not removing anything from this projectile pool. I guess you could say folder in a certain sense. What I want to do is return a reference, which is what take is doing, and through that reference activate the game object that I've returned. So here I've named it spawn. So spawn is a reference to one of the elements in this projectile pool. Again, going with our specific example here. And spawn.setActive, I can set it to true. So when I call spawn, it will take one of these projectiles. It doesn't really matter which one. It's not random with concurrent bag, but conceptually we don't really care which one of them they're taking. And we'll see it turn on. Like this one, let's say projectile 9 is selected, it will become on. And then the projectile will start moving like this. Okay, or let's say projectile 0 gets turned on, it will appear and start moving. Now, of course, where we want it to appear when we call spawn will depend on a few things. But the first thing is to, activate it. Now, you might think, in Unity, in this specific application of object pools, every time I'm going to take something from an object pool, be it from projectiles, maybe of enemies, maybe of particle effects or trees or whatever you want, I'm pretty much always going to want to activate it, right? So we can maybe simplify our code a bit. So this take method in our object pool component, which again is a model behavior, so this is Unity specific stuff, we can put that logic right here. So anybody that takes from an object pool component doesn't need to remember to activate what he or she takes. We're making things a bit more safe, I guess you could say. All right, so var, let's say, just going to call it obj here. obj.setActive to true. So yeah, I'm forcing some behavior here. I'm forcing that every time you're taking from an object pool component, you're activating at the same time, but I can't think of, at least very quickly, any reason why you don't want to do that all the time. All right, and finally, let's return that reference to an object. Cool. And while we're here, we probably can justify something similar for put, where every time we want to put something in an object pool component, we want to immediately deactivate it. So I'm actually just going to deactivate it before putting it into the data structure. Object to put dot set active false. The order doesn't matter here between line 32 and 33, but I just for some reason think it's nicer to deactivate before putting it in the data structure. Which means I don't need this line here anymore. Okay, cool. All right, let's go back to our spawner component and now allow the user to set a position and orientation for the spawned game object. So I'm going to do that through a transform. And I'm just going to call this like spawn point, I guess. Or spawn transform, since it's more than a point. All right, I might think of a better name later on, but let's carry on for now. So I'm going to take my spawn game object and I'm just going to set its position. So this is world position to equal, dot transform dot position, important. Okay. And I'm going to set it to my spawn transform dot position. And you can notice that I'm not caching the spawn transform position. I'm always going to be, getting it every time I'm spawning, because I'm considering the fact that a spawner will move around, during gameplay. Because I could have, once again, an enemy that has a weapon, and the weapon has a spawn component, and the weapon is moving around with the enemy, and I always want to spawn it, at the position associated with at the new position associated with the weapon. So this will take care of that. And same thing with the rotation. So I'm setting here global rotation. I could work with local space, but I'm trying to keep things simple for now. So spawn transform dot rotation. All right. So let's do some tests. I'm going to create a new game object here. I will call it, let's say, spawn tester. I will give it a spawner component. Okay. I'm going to plug in my projectile pool, which means I'm going to be taking from that pool, and spawn transform. So let's say in the spawn test, I'm going to create an empty here, and I'm going to call this like, I really can't think of good names tonight, so I'm just going to call it like S1 for like spawn transform 1, I guess. So I'm going to plug that in here. Okay. So again, you can think that this S1 might be like the exit point of an enemy weapon, like of a cannon. I showed you guys in the previous lab, I believe, like how to set up exit points for positioning projectiles with a cannon, I think. Now, okay, I'm just going to set this up. All right. Now let's test this out. So to test it out, we actually need something to call the spawn function, the spawn method of this spawner component. So I'm just going to create another component for that. I'm going to call it like spawner, or no, like spawn testing component. So it's kind of like if I'm setting up a unit test here directly in Unity. So I have like this specific script to test out my spawning behavior that I can use while I'm creating my game, just to validate that it's functioning as expected. So let's write some code for that. We're going to require a spawner component. So sorry, type of spawner component. I'm going to keep that in memory. So spawner component. I'm lazy right now, so I'm going to call it SC. Sorry about that. And I'm going to initialize that in my awake event. SC equals get component spawner component. And for the update, let's just monitor a key from the keyboard. So if input dot get key down, I'm going to hard code a key here. Keycode dot a, sure, why not? I'm going to call sc.spawn. Now, I don't think I've made any mistakes here, but something always ends up biting me back when I think I've did everything correctly, so let's hope. All right, so that did not work as expected. Okay, let's see what's going on here. I'm just going to place a breakpoint. just deactivate my spawner tester. Okay, they're all activated. I don't want them to be activated. Why are they all activated? Let's see. Object pool component. Maybe I did something weird. I'm sure some of you are screaming at me through your computer screen right now. So when I put, I set it to false. When I take, I set active to true. Well, this is embarrassing. Let's see here. Interesting. Why is this not working? Oh, of course. Yeah, I'm not calling this method here. This is the object pool. So our vanilla C# object that we're calling. So we're not setting active. I should be doing this instead. There we go. So now I'm calling this one that's as a byproduct, setting active to false. Okay. My apologies. Let's carry on now. Okay, so I'm going to press A, and there we go. 19 was activated. I'm going to press it again, A, and then pause. Okay, so here, what is my spawn point? And we can see that the projectile came out of there with that orientation. So let's say that I'm going to just change my spawn point now and change its orientation for like that. Okay, let's continue. I'm going to press A again, activating 17. Let's say I'm going to press one more time, and oh, there we go. So we can see that projectile 16 followed the correct direction and spawned at the correct location. So let's continue here. I'm going to press A a bunch of times. Okay, one more time now. Oh, object pool exception, error in the application. Right, so my projectile pool has everything set to active, which means that in the back end, the data structure of my object pool is empty. That's why I got this exception when I tried to spawn one more thing. So what happened is that I called spawn, so I called take. I called take here, which implies calling take here, which goes all the way here and checks with try take. This returns false, so I throw the exception and I see it appear here in my console. We need a condition where we put projectiles back into the object pool. Multiple conditions could exist in a given game. For example, it's pretty easy to think of a few with projectiles. Let's say the projectile collides with something solid, like an obstacle or another player or a wall. Well, instead of destroying the projectile, we just want to deactivate it, put it back in the pool for recycling. Now, what else could it be? Because that's not sufficient if you have a big open sky in your game and you're allowing your players to shoot up in the sky. Then your projectile could continue, indefinitely if there's no gravity or speed decay attached to it. Well, we could have like a timer, so we deactivate after a certain amount of time. Actually, let's go with that solution. Since we don't have anything really set up in our scene, let's say that after a certain amount of time, we want to deactivate a projectile and putting it back into the object pool, giving it a certain life cycle. our solution for deactivating projectiles after a certain amount of time is going to be quite involved. So take a break if you feel like you need it. This final part of the lab is going to be the hardest, unfortunately. So our solution is going to imply multiple components and even interfaces that we're going to see shortly. But the first thing is to create this callback timer component, which is pretty similar to the timer component from lab 1, where after interval amount of seconds, we're going to invoke a callback method. So we can see here on my projectile prefab, I've given it this callback timer component. I've set the default interval to 5 seconds. So at every 5 seconds, I want to call whatever I put in this callback list, which will eventually be our deactivate method that we have to write. Well, I said every 5 seconds. I put the here is one shot. So we don't want to deactivate it every 5 seconds. We just want to do it, well, one time. So one shot is checked. And we can look at the code. So pretty simple. Every frame, we are accumulating the time that has been passed. And if elapsed time is over our interval, we invoke all the methods in our callback list here. And let's say that it's not a one shot, so we want to repeat it every interval amount of seconds. Well, we take our elapsed time and just reduce it by the interval. But if it is one shot, we just immediately deactivate the component. And here I have a reset method that will reactivate the component and set elapsed time back to 0, effectively allowing the update loop to do its thing once more. Our second part now is to create this projectile component where we will write our deactivate method. And this method is going to get called in our timer. And I'm putting this projectile component onto my projectile prefab. So what I can do now actually is just connect things up like this. There we go. So after 5 seconds, we're going to call the projectile component's deactivate method. And we can actually see here in Writer one asset usage. So we can actually tell that, yeah, this is going to get called at least one time, or exactly one time. Now, how do we actually go ahead writing the code here? Just as a reminder, what we want to do is take our game object that's associated to this component, right? So we want to take a projectile game object and put it back in the appropriate object pool. So I know that if I do game object here, that returns the game object that that has this component, that has a projectile component. But where's my reference to the object pool that created said object, right? So I'm creating like 20 projectiles. Well, where's my reference to the object pool component that's creating those 20? Oh, actually, object to pool here, I have a problem. Just gonna fix that quickly. Okay, there we go. Yeah, so how do we fix that? Well, I'm going to need a member that's called associated pool somewhere. So I can affect that member and say, okay, your associated pool is this specific object pool. Or actually, to be more precise, this object pool component. And I'm going to put you back in that object pool component. So this is a good place to actually do it. Projectile component is a component that represents, let's say, a projectile in its entirety. So it's not as generic as, let's say, a move component or an object pool component. No, this is something that contains methods and data specific to projectiles. And projectiles will have an associated associated object pool component. We can already start thinking about a bunch of other like types of game objects per se that will also be pooled and will require an associated object pool. So what are examples of that? Enemies. Let's say we have an object pool of enemies. Well, each enemy needs an associated object pool, so we can put it back in once we want to deactivate said enemy for object recycling. Let's create an interface. Why not? We can already think of a few scenarios where multiple components, let's say projectile component and enemy component, are going to require an associated pool. And they will require a method for obtaining the associated object pool component and for also setting their object pool component. I'm going to create an interface called iPoolable for that. What is an interface if you're not familiar with Java and C#? Well, by the very off chance that you are familiar with Objective-C, where they're called protocols. No, I'm just joking. Let's talk about C++. So they are pure virtual classes, also known as abstract classes. In C++, there's no like specific keyword interface, but in Java and C# we have interface, just to force the person at compile time to only have like pure virtual functions in them. Well, actually, I say that, but that's old C#. In new C#, we can actually have implementation as well in our interfaces. But let's go with something like really basic here. And notice that I won't be using C# properties because I want to stay close to Java and C++. I'm not even sure if C# is taught in any of your programming courses and that you even know what C# properties are, so let's forget about that. I have these classic get and setter functions. So anything that is iPoolable must implement get associated pool and set associated pool. And I'm going to say that my projectile component inherits the implementation of model behavior, but implements iPoolable. And I can just do this quickly to generate these function signatures. So I have to implement here the get and setter. I'm going to bring them higher up in my class, and I'm just going to create this private object pool component. I'm going to call it associated pool. And I'm going to write these really trivial getters and setters. So I'm just going to return the associated pool in my getter, and in my setter I'm just going to set associated pool to this pool value. Okay. Now again in C#, modern C#, I think since C# 8 or maybe even 9, so even more recently, we could have this boilerplate code directly implemented into the interface as like a default implementation, and then if you wanted to, you could override that in implementing classes. But oh well, let's keep things quite vanilla. Now, this means that I can take my associated pool and put back the game object inside. Now that's great. However, we still have like one important problem. Associated pool is null. We're not affecting it anywhere. So let's try and think, what's the best place to initialize this value? Well, I'm going to save you some time and give you the answer right away. It's going to be in our object pool component, specifically in the fill pool method. So you can see line 24 here. On line 24, we are getting the iPoolable component from the cloned game object, and we're setting its associated pool to this being the instance of object pool component that's creating all of the objects. That's instantiating all of these objects, all these clones. So that takes care of that. Another note here about Git component iPoolable. What's great about using an interface is that things are a lot more versatile. Oops, why is my keyboard not working? There we go, okay. So let's say if I just did get component projectile component here, well, all of a sudden my object pool component becomes only good for one specific case, which is projectile component. So I can't use it for enemies anymore. If I go with the interface, I have higher level of abstraction, and this should work as long as the game object that I'm trying to clone has a component on it that is implementing iPoolable. So that is one caveat here. We have one flaw in our code, is that if the game object to pool, in other words, the one we're going to end up cloning here, does not have an iPoolable component, such as projectile component, we're going to get a null reference exception problem, because this expression is going to return null, null.setAssociatedPool. Well, you can see the error coming up. On line 13, I'm doing a quick check. I'm making sure that the object to pool, so the one I want to end up cloning and filling up my pool with, does indeed have an iPoolable component. And remember that anything that starts with debug, like this debug.assert, is going to get pruned out on the final release build. So this check will not even be part, because it's not really a runtime problem. This is more like a development time problem where somebody in the editor accidentally put an incorrect game object. They're putting something that they want to clone that doesn't have an iPoolable component. So it's not something that's meant to be pulled in an object pool to begin with. Let's finally test this thing out. So I'm going to press A. Okay, I'm spawning in projectile 19, which was the last one added to the object pool. And notice that, okay, after 5 seconds, it deactivated. The game object got deactivated, and the callback timer component also became deactivated, thanks to isOneShot being checked. Now, I'm going to press A again. Okay, and there we go. Projectile 19 got reactivated. Right off the bat, we can actually notice that the concurrent bag in our object pool really doesn't take and put randomly. So it's pretty, like, what would this be? It would be last in, first out. Here, notice that projectile 19 never deactivates once more. And that's because its callback timer component did not get reactivated. So the callback to deactivate projectile 19 again is not getting called. And that's because our callback timer did not get reset once we respawn projectile 19. Okay, let's press A once more. So here projectile 18 now, because as I mentioned, the concurrent bag works with this last in, first out idea. Okay, so projectile 18 now went back into the bag. So it was the last one back in, pressing A. Oops, A, here we go. And yeah, this one too has the same problem. Callback timer did not get reset. So let's try and find a way to fix this that's still pretty versatile, that will work for other components that need to be reset that aren't just callback timer component. What we're going to do now is create a new interface called iResetable. And everything that is iResetable will need to implement a reset method. So things that are iPoolable, for example, they usually need to be reset once they get taken out of their object pool or spawned. So in the case of projectiles, we need to reset its callback timer component. We should tag callback timer component as an iResetable component. So it should have a reset function, which we actually already wrote here, public void reset. So in the specific case of callback timer component, the implementation for reset should be setting it enabled true and elapsed time to 0. Let's say we had another iResetable component that's on projectiles, or maybe something completely different, but something that should still be, pulled into object pools. What could be a good example of that? Let's say a health component that has an HP value. So every time we take an object, let's say an enemy. So we have an object pool of enemies. Every time we take an enemy object out of the enemy object pool, we're going to want to reset all of its resettable components, thus taking its health component, calling the reset method of that health component, and resetting the enemy's health to some base value. Now to create this new interface, we have multiple ways. Here in Writer, what I'm going to do right off the bat is say everything that is iPoolable is also iResetable, because I can't think of many instances where we have an iPoolable object that won't need some sort of resetting. So iPoolable, iResetable, 2 T's, I'm thinking. Now, of course, this file does not exist, but I can just create interface iResetable here with Writer. Visual Studio should also have something similar to this to directly create this interface. Now, it's creating it in the same file, actually, which I do not like. I thought it was going to create a new file. So, okay, I'm just going to do this manually. Here in code, add new interface. I'm going to call it iResetable, and okay, there we go. The namespace here, I don't really want that, so I'm just going to remove it, remove the indent here. Okay, so public interface iResetable kind of looks like this public interface iPoolable. And I'm just going to say that everything that is resettable needs this void reset method. I don't recall saying this before, but everything that's declared in an interface in C# is public by default and not private like in classes, which makes sense. It could have been protected by default, but public also makes sense. Basically, we need something that is accessible outside of the interface itself, so something non-private, so we can override it and implement the function. Now I'm going to take my callback timer component and say, hey, you are iResetable. And as I mentioned previously, well, we already have that public void reset method implemented here. All right, so I'm picking back up the recording now after many days without touching this project. I'll do my best to remember everything, but if I do remember correctly, we created the iResetable, which contained this reset method, okay? And now I'm going to show you my projectile component, which is most likely different from what was written back a couple minutes ago. So let's just go over the differences now. I have this iResetable array called resettables, and resettables, which is the amount, I should say actually the number of elements in this resettables array. What else has changed? We have our reset method now. So for any projectile component, when we call reset on it, it's going to go through all its resettables in this for loop and reset them. So that could be a health component. It could be, in our particular case, this callback timer component. It could be a bunch of things that need to be reset once we pull an object out of the object pool. Okay, now let's go back to that. What else is different? Well, I need to populate and initialize, instantiate, whatever you want to call it, this resettables, right? So it's null. So here I'm calling get components in children. This will create an array, and I'm going to initialize resetables to that array. What will be contained in the array are a bunch of I resetables, but there is one more thing to consider. So get components in children, it's kind of a weird name. I would say it's inappropriate, because it doesn't just get components in the children of the game object that has the current component. It will also search in the, well, parent game object, the parent to these children. So iPoolable, right? If you are iPoolable, you also implement iResetable. So what does this imply? Well, okay, I have a projectile component. The projectile component is iPoolable, therefore it is also iResetable. Now I just said that here we're also, like getting the parent or the calling, we're searching within the calling component. So basically what I'm trying to say is that we're generating like this infinite loop because of this reset method. So get components in children will actually include not only all the callback timer components, well, I should say the callback timer component, right? Because this component will be on one projectile, and that projectile has one callback timer component. So the array that will be returned here, yeah, it will contain that callback timer component, but also the projectile component itself. And I'm resetting that one, which will, infinitely call a bunch of resets, because I'm infinitely resetting the projectile component, which then resets, well, itself, which resets itself, and so on and so forth until we get the Stack Overflow problem. Now, what are solutions to this? Well, isn't there a version of get components that, actually does what the the name implies, just looks in the children and doesn't do the search for an iResetable on the calling game object? Well, unfortunately, no. And there's no overload to, add like false here or something to select that option. Wait, actually, is there? Include inactive. Oh, I saw include and I got really, really hyped up for that. But no, I thought it was like include parent true or false, but no, include inactive. All right, so that is really disappointing. Now, there are user-made solutions. Like somebody actually made a LinQ version of game object with extensive extension methods, if that's what it's called, which allows you to just get the children and then just do your search within the children. But I don't want to go on GitHub and I clone that project and then include it in this one and make an already complex design pattern even more complex by adding third-party code. So the solution here is, as you might have noticed, my end resetables, I'm going all the way, well, not all the way to the end. I'm just omitting the last element in my end resetables. Now, here I am assuming that the last element in end resetables, the last element returned by get components in the children, will be that parent component, that parent iResetable. It will be that projectile component. So I'm just not resetting that last one, which solves the problem. This is assuming that it will always be at the end. And from what I remember and from my tests, that is the case. Now, I can't say that with 100% certainty because I haven't read it anywhere, but I'm pretty confident that's the case. Otherwise, well, then we could just, complexify this for loop and check if the, resetable at position I is the parent, and if it is, we just skip it. So it's not really fun to add checks in every iteration of the loop here, but that could be a solution. So yeah, I mean, this feels a bit hacky to me. It's not something that I'm particularly proud of, but I think it will get the job done for what we need. And sometimes that's what we should focus on. We should focus on what we actually need right now, and not be too what's the appropriate word? Not too picky about optimization. Okay, so what else? Let's look at object pool component, because I also made a modification here. A pretty simple one. I'm just saying that when we take a game object, we're going to reset it, which really means taking the iPoolable component attached on the game object that we want to pool and resetting it. So in our case, once more, it's this projectile component. And we know that anything that we should be pooling should be an iPoolable. So I don't remember if I put this line of code in the previous parts of the video, but here it is now. So I'm just like asserting that the game object that I want to pool does contain an iPoolable component, because everything relies on that. Okay, so let's say I have like this enemy component to represent an enemy. I say that that's iPoolable. I know that's also iResetable. So I'm guaranteed that I have this reset method. Speaking about other types of iPoolable components, so this projectile component, like all of this code and even the reset code, is most likely something you're going to be doing in something like an enemy component or anything else that is iPoolable. Even this deactivate, I mean, will be something similar, if not the exact same thing. So you might be telling yourself, Kyle, I hate this projectile component. It seems just like a lot of boilerplate code for some things that are really just associated to object pooling and not really like a projectile. So if you had a bunch of different components to represent different types of entities, like enemies once more, you'd pretty much have the same code again. And I really can't disagree with you. So I am trying to keep things somewhat simple, which I know sounds probably a bit ironic coming from me, but I think we're just going to accept this design flaw. And I don't think it's too bad for one reason. In C# 8 and C# 9, so more recent versions of C#, we can actually put a bunch of this stuff in the interface itself. We can even have like default implementations in newer interfaces. For example, I could just have, like deactivate or even reset in iPoolable right here. Wouldn't that be great? Like reset, oops, got my return type, like reset, and then just start implementing. But we can see here that, well, we're not allowed. Target runtime doesn't support default interface implementation. So it's saying that my target runtime doesn't support it, but it is aware that there does exist a runtime that supports it. And those are runtimes for C# 8 and C# 9. And we don't have those in Unity yet, because Unity is still like on this old version of .NET, and that's our runtime. So yeah, that kind of sucks. We can't use really cutting edge C# in Unity right now. .NET 5 just recently came out. It's not even in preview, like it's fully out, and it merged .NET Core and .NET Framework into this one unified great framework that is cross-platform. It's about time. And we can't use it in Unity, so that's really disappointing. But they are working on it. They're working on it, and it should come soon enough. And once that comes along, we won't really require all this, boilerplate code. We can put that in a default implementation in our iPullable interface. And if we do end up with projectile component or enemy component, it will actually be to contain relevant information to projectiles and not just this information which is pretty pertinent for any iPullable. Right? This is not really specific code to projectiles. All right, so I've addressed that. Now let's take a look at how all this comes through in execution.